In this video, I will show you how to do three things. First, we will find increasing intervals. Then we will find the location of points of inflection. And finally, we will find the location of a relative maximum. Part A, on what intervals is the graph of f increasing? Here's the chart of graphical relationships between f, f prime, and f double prime. Make sure you have this memorized. We need this part right here. F will be increasing when f prime is positive and decreasing when f prime is negative. So our strategy will be to find f prime and make a sign chart so we can see where f prime is positive and negative. F prime equals, we're just doing the power rule, so 2 times 18 is 36, so we have 36x minus, all right, bring that 4 in the front, reduce the power by 1, and you have f prime. Let's factor. These are all divisible by 4 and x, so let's bring 4x out in the front as a GCF. That's going to leave behind 9 minus x squared. You're probably noticing that this is the difference of two squares. So let's factor further by doing 3 minus x times 3 plus x. In order to make the sign chart, we need to know where f prime equals 0. Setting 4x equal to 0, we get x equals 0. Setting 3 minus x equal to 0, we get x equals 3. And setting 3 plus x equal to 0, we get x equals negative 3. Let's put these values on a sign chart. Make sure you label your sign chart as f prime and create a row for each one of these factors. So I'm going to put 0, 3, and negative 3 on the sign chart like this. Next, we need to decide if these factors are positive or negative in each interval, starting with 4x. Well, 4x will be negative wherever x is negative, so that will be here and here. 4x will be positive where x is positive, so that will be here and here. For the factor of 3 minus x, if x is exactly 3, you get 0. But any x value that's less than 3 will give you a positive number. So that's going to be this interval and this interval and this interval. For example, if x is 2, you have 3 minus 2, that's a positive number. For any x value that is greater than 3, this factor is going to be a negative number. For this last factor, an x value of negative 3 will give us 0. So this is sort of the cutoff. But any x value that's greater than negative 3 will cause the factor to be positive. So 3 plus x will be positive in these intervals and negative in this interval. For example, if x is 0, you end up with positive 3. So you have positive values to the right. But if x were, say, negative 4, that would give you negative 1. So you will have negative values to the left. But what about the overall sign of f prime? Just count the negatives. If we have 2 negatives, that's going to make a positive. If we have only 1 negative, that's going to give us a negative. If we have all positives, obviously that's positive. And here, again, we have 1 negative, so that's going to be a negative. Now remember, our ultimate goal is to find where the graph of f is increasing. And we remember that f will be increasing when f prime is positive. So that means f will be increasing in this interval and this interval. Let's write that up as a summary. So f of x is increasing for x values less than negative 3 and for x values on the interval from 0 to 3 because f prime is positive. Make sure you include this justification. Part B, at what x coordinates does the graph of f have a point of inflection? So remember, a point of inflection is where the function changes concavity For example, if it changes from concave up to concave down, you have a point of inflection. But let's reflect on those graphical relationships that we have memorized. F will be concave up when F double prime is positive, and concave down where F double prime is negative. So in order to find the points of inflection, we need to know where F changes concavity, and that will happen wherever F double prime changes signs. So let's find F double prime and make a sign chart. Taking the derivative of the first derivative, we have 36 minus, power rule, so 12x squared. So this is the second derivative, but both of these are divisible by 12. So let's go ahead and factor a 12 out. So that will give us 3 minus x squared. We need to know where F double prime will equal 0. 12 cannot equal 0, so that means 3 minus x squared must equal 0. Adding x squared to both sides, we have 3 is equal to x squared. And then taking the square root of both sides, we get x is equal to plus or minus the square root of 3. So let's put these values on a sign chart. Make sure you label your sign chart as F double prime. We only need the one row for 3 minus x squared because F double prime will be positive wherever this is positive and negative wherever this is negative. The positive 12 does not affect it. So will 3 minus x squared be positive or negative in each of these intervals? Keep in mind that the square root of 3 is approximately 1.7. So the first interval, we need a test value that is less than negative 1.7. For example, let's say negative 2. So if we did an x value of negative 2, we'd be looking at 3 minus negative 2 squared. That would be 3 minus 4, which would be a negative value. So F double prime is negative in the first interval. In the middle interval, let's use a test value of 0. You could definitely do this in your head, but if we did 3 minus 0 squared, that would just be positive 3. So we have a positive in this interval. In the last interval, let's use a test value of positive 2. Similarly to the first interval, we have 3 minus 2 squared, which again is 3 minus 4, which is negative. You can see that F double prime changes signs at both negative radical 3 and positive radical 3, which means that F changes concavity at both of these x values. So our summary statement is f of x has a point of inflection at x equals negative radical 3 and x equals positive radical 3 because F double prime changes signs. Part C, at what x coordinates does the graph of f have a relative maximum? Let's use the first derivative test. Remember that function f will be increasing where f prime is positive and decreasing where f prime is negative. Here's a copy of the sign chart that we created back in part A. Notice that f prime is positive in the first interval, so we know that the original function f would be increasing in this interval. Negative in the next interval means a decreasing function, and then we have a positive, so increasing, and then negative means decreasing. So this helps us visualize that at an x value of negative 3, we're going to have a relative maximum, and at x equals positive 3, we're going to have another relative maximum. We have a relative min at x equals 0. So here's how you would summarize and justify your answer. F of x has a relative maximum at x equals negative 3 and x equals positive 3 because f prime changes from positive to negative. In part D, we are again being asked to find the x-coordinates where the graph of f has a relative maximum. However, this time we are to use the second derivative test. To perform the second derivative test, We first find the critical numbers where f prime is either undefined or equal to 0. But f prime is defined everywhere because it is a polynomial. And we found previously that f prime is equal to 0 at x equals -3, 0, and +3. So these are the critical numbers. Next, we evaluate f double prime at each critical number. So here is f double prime at -3. If you work this out, you get -72. Now remember, where f double prime is negative, the original function is concave down. So that means that function f is concave down here, which means that the x value of x equals -3 must be a relative max. If you evaluate f double prime at 0, you get +36. A positive second derivative means that the original function is concave up, which means that the x value of -3 is a relative min. Evaluating f double prime at 3 gives us -72 again, which again means that the original function is concave down, making the x value of +3 a relative max. So here is our summary and justification. F of x has a relative maximum at x equals -3 and x equals +3 because f prime equals 0 while f double prime is negative. Notice that you need both parts to this justification because you must first establish that you have a critical number before you can apply the second derivative test.